Turning. It's one of many different ways of cutting a material. Drilling is another. It involves quite a different kind of cutting tool, one that produces holes. And from drilling to milling. This particular milling cutter is designed to operate at high speeds and feeds. It's producing a flat surface. Here we're turning brass. Engineers must be able to cut all sorts of different materials and on almost any scale. This is one of the largest lathes in the country. Industrial machines are often designed to take more than one cut at a time. Cutting tools are usually made of high-speed steel, but here the cutting edges are made from a much harder material, tungsten carbide. But whatever the tool is made of, or the cutting process involved, one thing must always be there: movement. On a shaper, the tool moves with respect to the work, cutting or generating a flat surface. The work is clamped to the machine and remains stationary during the forward or cutting stroke. During each return stroke, the work is moved sideways, ready for the next cut. Vertical drilling is a process where only the cutting tool moves. It rotates, generating a hole in the component. The component can't move, it's clamped in a vise fixed to the machine table. But there's more to it than that. The rotating drill must be fed or traversed into the work in order to cut. Milling is another process where the tool rotates. But instead of the tool being fed into the work is fed in towards the revolving cutter. In this way, a flat surface is generated. In the case of the lathe, it's the work that rotates with respect to the tool. The cutting tool can be fed into the work along the machine bed. Feeding in this direction, a cylindrical surface is generated. Using a different cutting tool, we can also feed into the work across the machine bed. In this way, a flat surface is generated.